I teach both at undergraduate and postgraduate levels on a range of molecular biology and genetical subjects, and I enjoy all of my teaching. But I'll tell you about a course that presents a particular set of challenges to teach. The course is called The Molecular Genetics of Disease, which runs for master's students in the biomedical sciences. There are just over 70 students in the class this year, with approximately half of the class from overseas. The particular challenge in teaching is due to the diversity of their background knowledge, in that they come from all different disciplines of biology. The undergraduate degrees span from A to Z, from anatomy to zoology and everything in between. Additionally, we even have some students whose first degree was not in a biological subject, such as chemistry or engineering. So I've had to develop a way to teach the class that does not bore half of the students because they find the topic too easy, or bore the other half of the students because they're out of their depth. The learning objectives for the course are several. On the one side, I do need to ensure that everyone becomes conversant with some basic concepts in molecular biology. So one objective is to increase the knowledge base of all of the students, whatever their starting point. But equally important in this course is to provide the students with the tools to become good scientists and to use scientific principles in their study. This is a master's course, and the students will be going on to conduct research projects on a wide range of topics in numerous different research labs. So through the course, they learn how to analyse and understand published scientific papers in depth. I encourage them to form hypotheses about questions to which they don't know the answer, not just go and ask Google, and how to examine those hypotheses and reject them if they don't stand up to the information at hand. So this course is about scientific process. Primarily, I make a lot of use of a kind of hybrid of problem-based learning, PBL, and student-directed learning, SDL, approaches. For example, in one set of sessions, I divide the large class into smaller groups, and I give them a scenario incorporating lots of questions on the topic under study. I ask them in their groups to explore the current knowledge base within the group to answer the questions, without referring to online material. So within each group, they reach a consensus of information. I go round the class and I facilitate this process by going from group to prompt and promote further questions, and to get all the students to hypothesize if there are questions to which no one knows the answer. The crux of a scientific hypothesis is to be able to test it, and from the results, accept or reject the hypothesis. By the end of each session, each group will have reached a point where their current knowledge and hypothesizing can go no further. This is when I provide a set of questions for each group to explore for their own study time. In the follow-up session, the groups again have the opportunity to discuss their findings in answer to the set questions, with each other and with me. And then each group presents the answer to their set question to the rest of the class. Using this approach, all students will acquire the basic concepts of the topic to a level they need going forward. And presumably this is, in part, why they nominated me as best teacher in the college, of which I'm immensely proud.